Hello everyone, welcome to the first part of the Chapter 2 notes videos. Here we're going to actually start doing some real work, I guess. We're not just going to be defining a bunch of words, we're going to be actually making some charts and graphs so we can start organizing some data that way. Here we have the most basic kind of a graph just to start with, which is called a frequency distribution. And this is one that is simply going to list how many of each observations we make for the different values that a variable can take. So in this example right here, we're talking about taking blood from 50 patients and then determining their blood types. And so the blood type is the variable. And we could discuss, for example, whether this is a qualitative or quantitative variable. It should be qualitative because this is just a way that we can categorize the blood types. They're not numbers, obviously. But we can enumerate how many possibilities there are, because there are four basic blood types. There's A, B, O, and AB. And then for this frequency distribution, what it means, the frequency is basically how many times we make that observation. And so out of these 50 blood types, we can come through and count all of these, and we would see that for the blood type A, there are apparently 18 of them. And then for the blood type B, there are 6 observations. And for the blood type O, we can count here that there are 22 of them. And then for the blood type AB, there are 4 observations. And so the frequency distribution, there are a couple of ways that we could draw an actual graph for this. But there's something that's even more meaningful than a frequency distribution. And that's going to be the thing that's called a relative frequency distribution. And so that's what we'll do next. We'll do it actually for this same set of data. But here, these kinds of numbers, like 18 for blood type A, it's not really as meaningful as understanding what the proportion is of A versus all the other blood types. Because here, if we just say, oh, we took a sample and there were 18 A's, what's really important is, how that compares to how many total observations there were. Because if there were 1,000 people and we got 18 A's, that's going to be a way different picture than if there were 20 people and we got 18 A's. And that's what it is with the relative frequency, is that we will actually come up with the proportion of observations for each possibility of the variable. And so we have a little formula for it here that we would just divide the frequency for a given value divided by the sum of all the frequencies, which is also just how many observations we have total. So we already know from the previous example that there were 50 observations. So the relative frequency, we should just take all of these frequencies and go out of 50. And so for blood type A, B, O, and AB, we can record that there were 18 of them, and so the relative frequency would go 18 out of 50. And then for B, it would go 6 out of 50. For O, it would go 22 out of 50. And then for AB, it would go 4 out of 50. And then we can actually write the percentage for these. I'll just write the percent in a decimal format. That this one, you could check, but it should go 36%. And since we're going out of 50 here, it's pretty easy to find the percent. You just double this number and put it behind the decimal. So this one should go 12%. This one goes 44%. And then AB lastly goes 8%. So this would be the relative frequency. And here we're getting closer to coming up with some ideas about which blood types are more common and which are less common, and we could also make some estimations about how many people we would find that have a particular blood type inside of a given sample size or inside of a given population. But we will carry on. We want to be able to graph these as well, not just come up with lists, but actually make some graphs that are nice to look at. And so we will have here the most basic type. This must be a throwback to elementary school, the bar graph. Where here we're going to draw a frequency bar graph for the blood types. And in this case, it just says frequency instead of relative frequency, even though the frequency and the relative frequency bar graphs would look exactly the same. You could, if it's not clear why, you could think about it for a little bit. They will look exactly the same. The only thing that's going to change are these numbers along the left. The relative frequency, can only max out at 1. But the actual frequency here, it's going to be based on our sample size. And so the most frequent one had a frequency of 22, and so we can make some type of a scale over here that's going to go up to 22 or else something in that vicinity, and you could draw different ones. In general, to make a good graph, we want the tallest bar to be pretty close to filling up this graph so we don't just have a lot of wasted white space at the top. But I'm going to make my scale like this. And here it actually works out for these bars to just be the even numbers. And this should do a pretty good job of filling up our whole bar graph and also capturing all of the values that we wanted. So the A's, if you remember, it went up to 18. And then the B's were 6, which looks like about there. The O's were the 22. And then the AB's were 4. And then we would come in here, fill in these bars. It doesn't have to look perfect. The key with a bar graph, which differentiates it from a histogram, is that the bars do not touch. In a histogram, they will touch, and we'll see a lot more about a histogram coming up here. But this would be a bar graph, and then we can come in here and make some nice colors. We could even give them a different color scheme. We can have a blue one, and you can make your bar graph however you would like. The key is that they don't touch, and we want to maximize the space. And so there we have a nice bar graph for this one. And as far as organizing qualitative variables go, we've got a couple of options for how to do it. A bar graph. We could also make a pie chart, for example, for the relative frequencies. But whenever we get into organizing the quantitative data, we have some more opportunities to make a nice graph for this one. And we've talked before about what it means, discrete versus continuous, and we'll see how those can affect which types of graphs that we can use. But here we will make a frequency chart the same way that we did for the blood types, but we're going to do it based on how many phones are in the household. So the number of phones in a given household. This one is going to be a variable. Of course, it's a discrete one. Besides just being quantitative, it's a discrete variable. And then the number of phones that are in the households were either 1, 2, 3, 4, or 5. Those were the values that are taken for this one. And then the frequencies, we can come through this list and we can count the number of ones, and there are 3 of those. And then the number of 2s, there are 7 of them. How about for the number of 3s, we can come through and count these. There are 11 of them. And then the 4s, there appear to be 6. And then the number of 5s, there happen to be 3 of them. And now we can make, for this one, a histogram, which is going to be very similar to a bar graph, except for we're not dealing with categories anymore. So actually, there's this idea that the bottom axis, the values, actually there's kind of a scale here that are ranging from least to greatest. So before, with the blood types going across this axis, there's not an obvious way to put them in order, for example. But here we can put them in order, and these little ranges that we make that will represent one bar, these are called the classes. And we'll talk a little bit more about the classes, but we don't have very many classes to choose from here. We actually just have the values 1, 2, 3, 4, and 5. And classes most of the time will represent ranges, but in this case, there are not enough values really to make use of ranges. We'll just have that each individual value will be its own bar. And so for the 1, there are 3 of them. Of course, we need to come up with a scale over here. And to make a really nice graph, we should also label the axis. I didn't make a very proper graph on the first one because I didn't say blood types over here. But these ones are number of phones in the house. And then we can label this one that this one is just the frequency. So we'll have it all the time that frequency is on the y-axis, and along the x-axis we will have whatever variable we're measuring. And so the frequency for these, they're going up to 11, so it looks like we could just go 2, 4, 6, 8, 10, 12, and this will do a pretty good one for us. And then 1, it goes up to the 3. The 2 goes up to 7, so that's about there. The 3 goes up to 11. And we're ending up with a very nice, fairly symmetric looking graph. And this is our histogram. And a little bit more to do with histograms we can talk about some terminology that is unique to histograms, or we're dealing with these things called the classes. And those are sort of the baskets, if you will, that are holding all of the different values. And we have the lower class limit, which is the smallest value that will land inside of that class. You will also have a largest value that should still fall within the same class called the upper class limit. And then the class width, be careful to notice that this is the difference between the two lower class limits, two consecutive lower class limits. That tells you how wide the classes are. And there's a way of going about really carefully determining how wide your classes need to be based on what data you have. And we have a little formula that you could use here, which is that to find the class width that is appropriate for your data, you should take the largest data value that you have in all of the observations, subtract the smallest data value from that one, and then divide by how many classes you're intending to have. And that's where the independent researcher would have a lot of choices about how many classes they want to have. And a lot of times you can change the way the graph looks pretty drastically by changing the number of classes. It will often give a better picture of the shape of the data if you're using more classes, but you don't want to have too many classes, because then you might end up with a lot of classes that have either one or maybe no members inside of there. No observations falling inside of that class. So you want to avoid that as well. But here we'll have a chance to make a histogram without knowing ahead of time what the width of the classes should be. And here we actually will have a range of data for these. But we've got here some data. What we would want to do to be able to use this formula is we need to figure out what the largest data value is and what the smallest data value is so that we can have a difference. And so it looks like throughout this one, the largest data value is the 95. And then the smallest data value should be one of these 12s. And we have already a bit of a prompting because there are 6 places here for us to write, so maybe we would like to have 6 classes. And now if we determine what the appropriate class width is, we should subtract 12 from 95 and divide by the number of classes, which is 6. And 95 minus 12, of course, is 83. If we divide by 6, we're going to end up getting a number that is in between 13 and 14, but closer to 14. It doesn't matter anyway because we want to round up to the nearest whole number. So it's close to 14. We will call it 14 because we want to round up and we would get 14. And so that's going to be the class width. Remember, that should be the difference between two consecutive lower limits. And so we will start out our first class with the lowest value, which was 12. And the next class is going to be 14 more than this on the lower limit, so the next one should be at 26. And so this one should go to anything between 12 and 25. And then this one, the next one, I like to figure out just what the lower class limits are, and then we'll subtract 1 from this one to get the upper limit for the previous one. But here, the lower limits should go like 40, 54, then 68, and then 82. And then the upper limits here then should be 39, 53, 67, 81. And then this one, we want them all to be the same width. And so we will go up to 90. Let's see, we can go up to 95. And it's convenient because that's our maximal value anyways. It's possible here that one of the ranges might not end on the largest value that we got, but it doesn't matter. As long as we're capturing all the data here, they're going to fall into some class. And so now we will come up with first the frequency that we have. We need to count how many there are, and they will all be out of 30, which is how many observations there are total. And so these will all go out of 30, but we need to count each one. And so here between 12 and 25, we need to come through and find them. And there are 6 of them. And then from 26 to 39, we'll find these. And there are 8 of them. And then between 40 and 53, we can find these ones. And there are 6 of those. And they're actually, for this frequency, there should have been, I think, 9 of them on second glance. But what about for 54 to 67? We can go there and count those. And there are 3 of them. For 68 to 81, we actually have 3 more. And then for the last class, oh, and actually there were 4 of them. It's very hard to count these, huh? But for the last class, there is just the lonely 1. That last one that we had as our maximal value anyways. And then we can always go back and count, make sure that these add up to 30 so we can be sure that we counted them correctly. And of course, they do not add up to 30. And if you're paying attention, maybe you noticed that actually there should have been 7 of these. And so now we're getting pretty close. We can at least start drawing this histogram because we have our classes over here, so we can make our classes. It's going to be hard to fit all these numbers in here. It's going to get kind of messy, but I'm just going to go number of credit hours. And we should have our 6 classes. I go 1, 2, 3, 4, 5, 6. And so we can understand that each of these little gaps, like here, this is going to be the first class. Second class goes in the next gap, and so on. I'm just not going to write them to make it too messy over here. And then this one goes frequency. And in particular, we want to do the relative frequency. And so we should actually come up with a decimal answer for each one of these by dividing by 30. And I'll do that now. And these relative frequencies that we get by making these divisions, I just rounded them to 2 decimal places, which is okay. Probably 4 would be better, but I was running out of room. And we want to be able to fill up this space. You know, we want the bars to basically go as tall as possible on the highest value. And since it goes up to 0.23, maybe we'll call this one 0.25 up here. And we'll just go by 5/100ths on these as the difference. And then we can have 0.05 as the lowest one. And now we can start making our bars. And so the smallest class is the one that goes up to 0.23, so it's pretty close up there. And then the next one goes 0.3. Oh, I actually want to add another one to a 0.3. I misspoke. And it's going to go up to 0.3. And then we have one that's 0.2. And then the next one goes 0.1. The next one goes 0.13, so a little jump up. And then the last one goes 0.03. This is what the histogram should look like. And then what if we want to answer this question, what percentage of students have successfully completed fewer than 26 credit hours? Fewer than 26 are basically all the ones in this bar. And that was around 23%. So I would say 23, it was basically 23.3%. This 3 is repeating. I'm going to go for that one. And now, moving on from the discrete variables, we are going to organize some continuous data into tables, which the continuous variables, they're still going to lend themselves nicely to a histogram, and we're going to have the same sort of an idea as we had before. We need to figure out what the class width is going to be, so we need to take the largest value, which is 76. We need to subtract the smallest value, which is 60, and then divide by the number of classes, which we're going to end up with 4 classes. This one, of course, this is an arbitrary value, the 4. I'm just going based off the table that is drawn here. And so this goes 16 out of 4, which is 4. So the class width will be 4. We need to start with the lowest value of 60, so it's going to go, the next one will be 64, and then 68, and then 72. And they're going to range up to, notice here that the continuous nature of these ones, this is going to go up to just before 64. But we don't want to stop it at 63 because then anything between 63 and 64, it's not going to be inside of the, inside of any of the classes. And so we have to be careful about how we name these upper limits. And based on the data here, I'm just going to be safe by calling it 63.9. That would capture anything that goes up to 64 because we don't have anything, that's 0.99 or something like that. So this one will go up until 67.9. This one will go up to 71.9. And then this one will go up to 75.9. Should be the next one. But really we would just call it 76 to make sure that we get the last value. And then we will come through and count how many times each one of these observations occurs. And since these values, they almost look like they're in order, but they're not, so it's a little bit tricky to count them. But we should get these frequencies, and then they're all out of 32. And so we can divide each one of these numbers by 32, and we will get all of the relative frequencies, which we should get some values like these, and then we are ready to answer this question: what percentage of students are between 65 and 69.99 inches tall? Which, again, it's a little bit awkward to answer this question because that's not one of our upper bounds. This is not a class in general, but we could find all of the observations that are between 65 and 69.99, and I'm fairly confident that there are 13 of them, so it would be 13 out of 32, which that's 41%. And now we're going to make a histogram. Of course, we should be careful to label, as always, and so these are going to go the heights, and this time we can put some very nice units, which are inches, and then this one's going to go relative frequency, and we'll figure out what is the largest relative frequency, and then our graph hopefully should end around there. And this labeling scheme seems to work okay, and then we will come in with our classes and we will draw the heights for these bars. So this one's going a little bit above the 30%. The next class is our tallest one, and then we will have our next class, which goes up to 0.19, so just below the 0.2, and then finally we have our class that goes up to the 9%. And that does it for our histogram study. Before we get into some of the other types like stem and leaf plot and so forth, to finish up looking at things for Chapter 2, I'm just going to break this video off here, and I will catch you guys in the next one. Thank you.